June 16, 1944, Normandy, France. German Field Marshal Erwin Rommel stood at the center of a crisis unlike anything the Wehrmacht had ever faced. 10 days earlier, Allied forces had landed on the beaches of Normandy, in the largest amphibious invasion in history. German commanders had expected fierce fighting. They had expected air attacks, naval bombardments, and endless waves of infantry. But they had also expected something else. A problem every invading army had faced for centuries. Without a major port, the Allies should have struggled to move supplies ashore. Tanks needed fuel. Artillery needed ammunition. Troops needed food. Every day, thousands of tons of equipment had to cross the English Channel and reach the front lines. German planners believed this logistical reality would eventually slow the invasion. Instead, something strange was happening. The Allied buildup was accelerating. More vehicles appeared every day. More artillery, more ammunition, more troops. The beaches seemed to be functioning like a giant port, even though no major port had been captured. Reconnaissance reports began describing unusual structures off the Normandy coast. From the air, they looked almost impossible to identify. Massive concrete blocks, floating roadways, breakwaters stretching across the sea. German officers struggled to understand what they were seeing. The answer was astonishing. The Allies had not captured a harbor. They had brought one with them. Hidden behind the headlines of D-Day was one of the greatest engineering projects of the Second World War, the Mulberry Harbors, artificial ports built in Britain, transported across the English Channel and assembled off the coast of France while a war was raging around them. For many German officers, the discovery seemed almost unbelievable. But the story of how an entire harbor crossed the sea began long before the first Allied soldier stepped onto the beaches of Normandy. Long before a single Allied soldier landed in Normandy, planners on both sides understood one fundamental truth of warfare. Armies do not move on courage alone. They move on fuel, ammunition, food, spare parts, medical supplies, and countless other necessities. Without a steady flow of supplies, even the most successful invasion can grind to a halt. This reality haunted Allied planners as preparations for Operation Overlord intensified in 1943 and early 1944. General Dwight D. Eisenhower and his staff faced a challenge unlike any previous amphibious operation. The invasion force would eventually include millions of men and hundreds of thousands of vehicles. Every item needed to cross the English Channel and reach the battlefield. The obvious solution was to seize a major French port. The problem was that German commanders knew this too. Ports such as Cherbourg, Le Havre, and others along the French coast had been heavily fortified. The Germans expected the Allies to target them early because no large army could survive for long without a harbor. Field Marshal Gerd von Rundstedt and many German officers believed logistics would become the Allies' greatest weakness. Even if the landing succeeded, supplying the invasion force seemed far more difficult than getting it ashore. The numbers were staggering. Within weeks of D-Day, Allied armies would require thousands of tons of supplies every single day. Beaches could handle some unloading, but rough weather, tides, and congestion would eventually create bottlenecks. History appeared to support the German view. Large invasions traditionally depended on capturing established ports as quickly as possible. Yet Allied planners had already reached a troubling conclusion. Trying to seize a major port during the opening stages of the invasion could cost enormous casualties and potentially delay the entire campaign. If they couldn't capture a harbor immediately, they would have to do something that had never been attempted on this scale before. They would have to create one. And hidden across Britain, engineers were already working on a project so ambitious that many experts doubted it could ever function in the open waters of the English Channel. The idea sounded almost absurd. If the Allies could not capture a port immediately after landing in France, why not build one themselves? The concept had circulated in various forms for years, but by 1942 it began attracting serious attention inside British planning circles. Prime Minister Winston Churchill became one of its strongest supporters. He pushed officials to explore the possibility of creating portable harbors that could be transported across the English Channel and assembled near an invasion beach. Turning that idea into reality was another matter entirely. The English Channel was notorious for rough seas, powerful tides, and unpredictable weather. Any artificial harbor would need to withstand forces that regularly damaged permanent structures built on land. engineers faced a challenge that many considered impossible. Across Britain, shipyards, construction sites, and factories quietly began work on a massive secret program known as the Mulberry Project. Its components were unlike anything previously built. The largest pieces were the Phoenix caissons, enormous hollow concrete structures weighing thousands of tons. Once towed to France, they would be deliberately sunk to form protective breakwaters. Additional defenses came from old ships, called gooseberries, which would also be scuttled to calm the waters behind them. Further offshore, engineers designed floating breakwaters known as bombardons to reduce the impact of waves before they reached the harbor itself. But perhaps the most remarkable invention was the whale roadway system. These floating steel roadways could rise and fall with the tides, while allowing trucks to move directly from ships to shore. It was essentially a floating highway built across the sea. The scale of production was enormous. Thousands of workers, engineers, welders, and construction crews participated in the effort. Components were manufactured in different parts of Britain, often under strict secrecy. Even many military personnel had no idea what was being built. Yet designing the harbor was only the beginning. The real test would come when the Allies attempted something no nation had ever done before: tow an entire port across open water and assemble it in the middle of a war zone. In the days following D-Day, on June 6, 1944, the English Channel became the scene of one of the most extraordinary engineering operations in military history. The invasion beaches were secure, but the clock was already ticking. Every day, Allied forces pushed farther inland. Every mile advanced increased the demand for fuel, ammunition, vehicles, and replacement troops. The temporary beach supply system was working, but it could not support the growing scale of the campaign indefinitely. Now the Mulberry Project had to prove itself. Across southern England, hundreds of tugboats and support vessels began moving the harbor components toward Normandy. The journey was slow and delicate. Many of the structures being towed were enormous. Some Phoenix caissons stood several stories high. Others stretched the length of city blocks. The crossing itself required careful coordination. Convoys moved through waters still threatened by German aircraft, submarines, naval mines, and coastal artillery. Every component had to arrive in the correct sequence. A single major disruption could delay construction of the entire harbor. When the pieces reached Normandy, engineers faced another challenge. They had to assemble a functioning port while combat continued nearby. The first step involved sinking the giant Phoenix caissons in carefully planned positions. One by one, the concrete structures settled onto the seabed, creating protective barriers against incoming waves. Old ships were then scuttled to strengthen the breakwater system. Behind these defenses, crews connected floating piers and the innovative whale roadways. The work continued around the clock. Engineers battled tides, changing weather, and the constant pressure of supporting an active military campaign. Within days, something remarkable began to emerge from the sea. Where there had once been only open water, there now stood an artificial harbor capable of unloading ships and moving supplies directly to shore. The achievement stunned many observers. Yet the most surprising reaction would come from the Germans. As reconnaissance, flights, and intelligence reports revealed what was happening off the Normandy coast, officers struggled to understand how the Allies had managed to create an operational port almost overnight. And for some German commanders, the implications were deeply alarming. At first, German intelligence struggled to interpret what it was seeing. Reconnaissance aircraft flying over Normandy reported unusual formations offshore. Pilots observed long lines of structures extending into the sea, clusters of large concrete objects, and growing numbers of cargo vessels operating behind protected waters. The reports sounded confusing. Some analysts initially assumed the Allies were constructing temporary unloading facilities. Others believed the structures might be defensive barriers or damaged ships gathered near the beaches. But as additional photographs arrived, a startling picture emerged. The Allies were not simply unloading supplies, they were creating an entirely new port. For German commanders, this conclusion challenged decades of military thinking. Throughout history, invading armies depended on existing harbors or captured ports to sustain major offensives. Building one from scratch in enemy territory was considered impractical, especially on the scale required to support Operation Overlord. Field Marshal Gerd von Rundstedt and other senior officers already faced a growing crisis. Allied air power dominated the skies. German troop movements were constantly disrupted. Rail networks throughout France were under relentless attack. Now, another assumption was collapsing. Many German planners had believed that supply shortages would eventually slow the Allied advance. If the beaches became congested or bad weather interrupted unloading operations, the invasion might lose momentum. Instead, Allied logistics were becoming stronger each week. German intelligence officers recognized that the Mulberry system represented more than an engineering achievement. It reflected something deeper about Allied war production. The harbor itself was evidence of vast industrial resources, long-term planning, and the ability to coordinate thousands of specialists across multiple countries. The project exposed a growing imbalance. Germany still produced impressive weapons and fought fiercely on the battlefield. But the Allies increasingly excelled at solving operational problems through organization, engineering, and mass production. The realization was unsettling. If the Allies could transport a harbor across the Channel, what other logistical obstacles could they overcome? That question became even more important after nature itself appeared, ready to destroy the Mulberry Project, and unexpectedly revealed just how resilient Allied logistics had become. Just 2 weeks after D-Day, the Mulberry Project faced a test no engineer could control. Between June 19 and June 22, 1944, a powerful storm swept across the English Channel. It was one of the worst channel storms experienced in decades, and struck directly at the newly established harbors off Normandy. The results were devastating. The American harbor, known as Mulberry A at Omaha Beach, suffered catastrophic damage. Floating piers broke apart, roadways twisted under the force of the waves. Sections of the harbor became unusable. For a moment, it appeared that German assumptions might finally be proven correct. If the artificial harbors failed, Allied supply operations could face a severe crisis. But that crisis never fully materialized. Although Mulberry A was eventually abandoned, the British harbor, Mulberry B at Arromanches, survived. Damaged sections were repaired and operations resumed. More importantly, Allied logisticians adapted quickly. Supplies continued arriving across the beaches using landing craft, amphibious vehicles, and an increasingly efficient unloading system. The storm revealed something crucial. The Mulberry Harbors were not the sole reason Allied logistics succeeded. They were part of a much larger network of planning, engineering, shipping, and organization that had been developed over years. Even so, Mulberry B became one of the busiest ports in the world. Through the summer of 1944, it handled enormous quantities of cargo. Hundreds of thousands of soldiers, tens of thousands of vehicles, and millions of tons of supplies passed through the Normandy beachhead. Fuel, ammunition, food, spare parts, and reinforcements flowed steadily toward the advancing Allied armies. Meanwhile, German forces struggled with mounting shortages. Fuel became increasingly scarce. Transportation networks were shattered by Allied bombing. Replacements arrived slowly. Every week widened the logistical gap between the two sides. By the time Allied troops broke out of Normandy during Operation Cobra in late July 1944, the outcome was becoming clear. The battle was not being decided by a single weapon or a single commander. It was being won by a system capable of delivering an entire army, and everything that army needed to fight. When German officers first examined reports from the Normandy coast in the summer of 1944, many struggled to comprehend what had happened. An invading army had crossed one of the world's most challenging stretches of water, landed on heavily defended beaches, and then solved its greatest logistical problem by building an entirely new harbor in the sea. The Mulberry Harbors were not the largest weapons of the war. They did not fire shells, sink battleships, or engage enemy aircraft, yet their impact was enormous. They demonstrated that victory in modern warfare depended on far more than battlefield tactics. Engineering, industrial capacity, planning, transportation, and organization could shape the outcome of a campaign just as decisively as tanks or artillery. For the Allies, the Mulberry Project helped sustain the invasion that would eventually liberate Western Europe. For Germany, it was a stark reminder that they were facing an opponent capable of solving seemingly impossible problems through coordination and production on a massive scale. Years later, military historians would continue to study the artificial harbors as one of the greatest engineering achievements of World War II. Because in Normandy, the Allies did something that sounded impossible. They didn't wait to capture a port, they built one. And in doing so, they revealed a truth that helped define the war itself. Behind every army at the front stands an invisible machine of logistics, and sometimes that machine can change history.